Hello guys and welcome to this lesson. In this video we are going to solve these questions I have here. Okay, so let's get started. So we have the first question which says that find the equivalent resistance of the circuit below. It says find the equivalent resistance of the circuit below. So let's go ahead and look at that. So I will redraw the circuit. Okay, we have this circuit. Let me redraw it. Okay, so this is the circuit, and then we have 5 ohms here, we have 4 ohms here, we have 3 ohms here, we have 2 ohms here, we have 1 ohm here. Okay, and then this is the voltage source. Okay, so the question says that we should find the equivalent resistance of the circuit. Okay, so let's look at how we are going to do this. So if you look at this circuit here, okay, assuming the current is coming from the current source, when it gets to this node, it will split into two. Okay, then when it gets to this node, because there is no element here, then there are some resistors here, the current will not like to pass through the branch where there are resistors. Okay, so all the current will flow through this empty branch here and then go back to the voltage source. So as a result of that, the 4 ohms and then the 5 ohms resistors will be short circuited. Okay, so this would be our circuit now. This will be our circuit now. So the 4 ohms and then the 5 ohms resistors will no more be part of the circuit. So let's clean them away and then focus on what you have now. Okay, so now this will be the circuit now. So let's calculate for the equivalent resistance. So you see that the 2 ohms and then the 3 ohms resistors are in parallel connection. So we're going to have 2 parallel 3. Okay, and then at the end they will be in series with the 1 ohm resistor. So we're going to have plus 1, right? So let's simplify this. We're going to have 2 times 3 divided by 2 plus 3, okay, plus 1. So let's simplify this. 2 times 3, okay, will give us a value of 6, and then 2 plus 3 will give us 5 plus 1. So let's see what we're going to get. So 6 on 5 plus 1, okay, will give us a value of 11 on 5, okay, which is equal to 2.2 ohms. Okay, so at the end that will be the effective resistance in this circuit that we have here. Okay guys, so let's solve the second example also. Okay, so for that one also, let me draw the circuit. we have we have 4 ohms here, okay, and then we have 3 ohms here in this branch in addition to the voltage source. This is 3 ohms. We have 4 ohms here, and then we have 2 ohms here, okay, and then we have a short circuit here. Okay, so this is our circuit, and then you have to find the supply current. Okay, so let's look at that. So assume you have a current from the source. Okay, what will happen is that when the current gets to this node, okay, it will like to split, right? But when the current takes this direction, okay, it will come and meet the 4 ohms resistor there. But when it takes this direction, it will not meet any resistor here, right? So all the current will flow through this direction, okay. And then when it gets here also, there's a 2 ohms resistor here, but there's no resistor in this branch. So the current will flow through this branch and then to go back to the source. So at the end the 4 ohms and then the 2 ohms resistors will be short circuited. Okay, so we are going to have the current to be equal to the voltage divided resistance, and then our voltage is 5 and then the resistance is 3 ohms. Okay, so that'll be 3, so we are going to have 5 over 3, okay, and then that'll give us a value of 1.67 amperes. Okay, so that's for this question also. Okay, so now let's move on to the next question. Okay, so now let's look at the next question. The next question says that what is the effective resistance of the circuit below? So I have the circuit here. Okay, so let's find the effective resistance. Okay, so what will happen is that these 2 ohms and these 2 ohms resistors are in series. This and this are also in series, right? So let's focus on those two. So on the left side, I'm going to have 2 plus 4, which will give us 6. And then on the right hand side, I'm going to have 2 plus 2, okay, which will give us 4, right? And then the 6 and the 4 are going to be in parallel with each other. So I'm going to have 6 times 4 divided by 6 plus 4, and then they're going to be in series with the 1 ohm resistor. So let's simplify that. So I'm going to have 6 times 4, okay, which will give us a value of 24, then 6 plus 4, which is 10 plus 1. So then we are going to have 24 on 10, okay, plus 1. And then this will give us a value of 3.4 ohms. Okay, this will give us 3.4 ohms. That's the answer for the third question also. Alright, so now let's focus on the fourth question. It says that find the total resistance of the circuit below. Okay, find the total resistance of the circuit below. So now let's draw that circuit also. So we have this circuit, we have one resistor here, okay, we have another resistor here, and then this is the voltage source, okay. Okay, so we have 3 ohms here, we have 2 ohms here, we have 6 ohms here, and then we have another resistor crossing like this, which is 4 ohms, okay, which is 4 ohms, okay. So now let's go ahead and find the effective resistance. Okay, so what will happen is that this 6 ohms here and then these 4 ohms resistors are going to be in a parallel connection, and then at the end they will be in series with these 2 ohms. Okay, so let's focus on that. We're going to have 4 parallel 6, okay, plus 2, right? This is what you're going to have. So you're going to have 4 times 6 divided by 4 plus 6, okay, plus 2, okay. So you're going to have 24 divided by 10, okay, plus 2, right? So let's see what you're going to get. So 24 on 10 plus 2, that gives us a value of 22 on 5 ohms, right? And then this 22 on 5 ohms will be in a parallel connection with this 3 ohms here, right? So you're going to have 22 on 5 parallel 3. Okay, so let's focus on that. Let's focus on that. Okay, so we are going to have 22 on 5 times 3, right? Divided by 22 on 5 plus 3. So let's simplify this. Let's see. 22 on 5 times 3 will give us a value of 66 on 5. And then 22 on 5 plus 3 will also give us a value of 37 on 5. Okay, so let's divide these two. So we have 66 on 5, okay, divided by 37 on 5, right? So then you're going to have 66 on 5 times 5 on 37. Okay, this will cancel out this, and then you're going to have 66 on 37. Okay, so let's what you're going to get. 66 on 37 will give us a value of 1.783 ohms. Okay, so that will be the effective resistance for this also. Okay guys, so let's move on to the next question. Okay, the question says determine the effective resistance between the terminals A and B of the circuit below. Okay, so let's look at that also. So let me draw the circuit here. Okay, so this is the circuit. We have another resistor here. Okay, Okay, so this is 3.3 ohms. We have 1 ohm here. We have 4 ohms here. We have 4 ohms here. We have 4 ohms here again. We have 6 ohms here. We have 3 ohms here. Okay. Then this is terminal A and then terminal B. So you have to find the effective resistance across those two terminals. Let's look at how you are going to do this. This 6 ohms and then the 4 ohms resistors are going to be in a parallel connection. Okay, you're going to have 4 parallel 6. You're going to have 4 parallel 6, and then at the end they will be in series with the 3 ohms resistor. Okay, which is this 3 ohms. Okay, so let's take note of that. So you're going to have 4 times 6 divided by 4 plus 6 plus 3. Okay, so this will give us a value of 24 on 10 plus 3. Okay, so let's simplify this. We have 24 on 10, okay, plus 3. Okay, this will give us a value of 27 on 5 ohms. Okay, 27 on 5 ohms. Okay, okay, so now what will happen is that this 27 on 5 ohms, okay, will be in a parallel connection with the 4 ohms here. Okay, let's redraw the circuit and see what we are going to have. So we are going to have a circuit of this kind. Okay, so this will be the circuit. Okay, okay, so we are going to have the 27 on 5 ohms here. Okay, and then we have 4 ohms here. Then we have 1 ohm here, and then 3.3 ohms here. So now you see that the 27 on 5 and then 4 ohms resistors are in a parallel connection. Okay, so you're going to have 4 parallel 27 on 5. Okay, this is what you are going to have. Okay, so let's simplify this and see what you're going to get. You're going to have 4 times 27 on 5, right? All this divided by 4 plus 27 on 5. So let's simplify this and see. I'm going to punch everything at once. Okay, so you have 4 times 27 on 5. Okay, divided by 4 plus 27 on 5. Okay, so this will give us a value of 108 on 47. Okay, so at the end, we are just going to have a circuit like this. We're going to have a circuit like this. Okay, this will be the circuit now. Okay, so we're going to have the 108 on 47 here, and then we're going to have 1 ohm here, and then we're going to have 3.3 ohms here. Okay, I have to clean this from here. Okay, so this is terminal A, this is terminal B, right? So you see that the 1 ohm and then 108 on 47 are in series, so we are going to add them. 108 on 47 plus 1. Okay, let's see what you're going to get. So that gives us a value of 155 on 47. So this will be in parallel connection with the 3.3 ohms. Okay, so let's take note of that. So we are going to have 155 on 47 parallel 3, right? So let's do the calculation. We are going to have 155 on 47, okay, times 3, right? All this divided by 155 on 47 plus 3. Okay, this is what you have. So let's simplify this and see. So we have 155 on 47 times 3, okay, divided by 100 3.3, okay, 3.3, not 3, 3.3, okay, okay, multiplying 155 on 47, multiplying 3.3 divided by 155 on 47 plus 3.3. Okay, let's see what you're going to get. Okay, so this will give us a value of 1.6 5, okay, ohms. Okay, so that will be the effective resistance. Okay, so now let's move on to the next question also. Okay, so this is the next question, which says that we should find the resistance seen between terminals A and B in the circuit below, which is question 5. So I have the actual circuit here, okay, and then I'm going to redraw the circuit. Okay, so let's look at that. Let's look at how I'm going to redraw this circuit. So I start with the 6 ohms resistor, the top here, right? And then from the 6 ohms, okay, we're going to have another 6 ohms here, okay. We're going to have another 6 ohms here, right? And then we're going to have another 6 ohms here, okay. We're going to have another 6 ohms here, okay. And then you see from this circuit you can get a lot of delta connections here, but you just have to choose the one that will be easy. I'm choosing the top side because all the values are 6 ohms, okay. So finding one will just give us an idea of what the rest will be, okay. So that's for the top side of the circuit, okay. So at the end I'm going to have my 3 ohms here, right? And then I will have another 3 ohms here, okay. I have another 3 ohms here, and then we are going to have another 3 ohms here, okay. We have another 3 ohms here, and then this should be terminal A, and then this should be terminal B, okay. So I've transformed the circuit, okay. We have 3 ohms here, okay. We have 3 ohms here, we have 3 ohms here, and then we have 3 ohms here, okay. So now this is the circuit now. You are going to change this to a star connection, right? Which is the delta connection you have at the top. You're going to change it to a star connection. Okay, so let's look at that. Okay, so we are going to have something like this. Okay, so let's name this A, let's name this B, let's name this C. Okay, so finding A, okay, finding A, we are going to have RA, okay, we're going to have RA to be equal to RB, okay, times RC, okay, divided by the total, which would be what? RA plus RB plus what? RC, okay. But because all the values are 6 ohms, we are going to get the same answer for all of them, okay. So let's calculate for just RA, then that will be the same for RB and then RC. So we're going to have 6 times 6, okay, divided by 6 plus 6 plus 6. So let's go ahead and look at what you're going to get. So 6 times 6, okay, divided by 6 plus 6 plus 6, that will give us a value of what? 2 ohms, which means that each of the resistors in the star connection has a resistance of what? 2 ohms. Okay, so now let's redraw the circuit that we have. Okay, let's redraw the circuit. We have this circuit here. Okay, now we have a star connection instead of the delta connection. Okay, this is what we have now. Okay, and then we have another resistor here. Okay, and then this should be terminal A, okay, this should be terminal B, okay. So we have 3 ohms here, and then we are going to have 2 ohms here, right? Then we are going to have 2 ohms here again, okay. And then in the middle, okay, in the middle, what will happen is that we're going to have 2 resistors in the middle, right? Which one will be this 3 ohms, okay, and then one will be this RA resistor. Okay, so let's take note of that. So I have the RA here, and then I have the 3 ohms also there. So this will be 2 ohms, and then this will be 3 ohms, right? And then we have another 3 ohms here. Okay, so this will be the circuit that you are going to use to find the effective resistance. So let's look at that. These 2 and these 3 are in series. These 2 and these 3 are in series, so we can add them, right? So for the middle, we are going to have 5 ohms, and then for this side also, we are going to have 5 ohms, right? So now let's redraw the circuit. Let's redraw the circuit. We have 2 ohms here, right? And then we have one here, we have another resistor here also. Okay, so this is terminal B, this is terminal A. We have 3 ohms here, we have 2 ohms here, and then we have 5 ohms here, we have another 5 ohms here. So you see that those two 5 ohms resistors are in a parallel connection. So we're going to have 5 parallel 5, and then at the end they will be in series with these two. So you're going to have plus 2. Okay, so you're going to have 5 times 5 divided by 5 plus 5 plus 2. Okay, so let's see what you're going to get for that. So 5 times 5 divided by 5 plus 5 plus 2, okay, will give us a value of 9 on 2 ohms. Okay, 9 on 2 ohms. Okay, so this 9 on 2 ohms will now be in a parallel connection with the 3 ohms, okay, which is this 3 ohms here. So I'm going to have 9 on 2 times 3, okay, divided by 9 on 2 plus 3. Okay, so let's simplify this and see if you are going to get the answer. Okay, so you're going to have 9 on 2, okay, times 3 divided by 9 on 2 plus 3. Okay, that's what you're going to get. Okay, so this will give us a value of 1.8 ohms. Okay, that gives us a value of 1.8 ohms. Let's compare to the answer that I was given. Okay, so that's 1.8, so that's correct. So now let's move on to the next question. Let me free up some space, then we continue. Okay, so I have this example here also. Let's find the current that is flowing through the 1 ohm resistor in this circuit, which is question 6. So let's look at how you are going to do this. First, to be able to solve this question, the first thing I'll do is to find the effective resistance of the 4 ohms and then the 1 ohm resistor. Okay, and you know they are in parallel, so you're going to have 4 parallel 1. Okay, so we are going to have 4 times 1, okay, divided by 4 plus 1. Okay, so that gives us a value of 44 on 5 ohms. Okay, we are doing this because we want to know the current that is flowing through this branch here. Okay, that's all we want to know. Let's name this as I1. Okay, so our goal here is to find I1. So let's look at that. So with current division rule, we are going to have I1 to be equal to the total current, which is 20 ohms. Okay, multiplying the 2 ohms, okay, which will be 2 divided by the 2 plus 4 on 5 ohms. Okay, this is because when we redraw this circuit after combining 1 and 4, we are going to have this circuit here. Okay, we are going to have this circuit here. Okay, so here will be 4 on 5 ohms, and then here will be 2 ohms, right? And this is the current coming from the source, which is of 20 amperes, and then this will be I1. Okay, that will be I1. Then this will be what I1. Okay, and then that's what you are looking for. Okay, so now let's go ahead and calculate for I1. We're going to have 20 times 2 on 2 plus 4 on 5. Okay, that gives us a value of 100 on 107 amperes. Okay, so the 107 amperes will be the current that will be flowing through this node here. So I'm going to use current division rule to find the current flowing through the 1 ohm resistor, which I'll name as I. So I'm going to have I to be equal to 100 on 7, okay, times, okay, 4 on 4 plus 1, right, which will give us 100 on 7 times 4 on 5. Okay, this is what you're going to have. So let's see what you're going to get. So we have 100 on 7, okay, multiplying 4 on 5, okay, that will give us a value of 11.43 amperes. Okay, so that'll be the current flowing through the 1 ohm resistor. So now let's go back. Let's continue with the question 7. Okay, so let me draw the circuit for question 7 also. So we have this circuit here. Okay, so I have 1 ohm here, we have 4 ohms here, we have 2 ohms here, and then we have the current from the source to be 10 ampere, right? And then we have I here. Okay, so the question says that determine the value of I in the circuit below. It says you should find the value of I in the circuit. So let's look at how you are going to solve this question. Okay, so just like the previous one, okay, just like the previous one, I will be the current that will be flowing through the 4 ohms resistor. So let's look at how you are going to find this. Before you can find I, you must know the current that will be flowing through this branch, which are known as I1. Okay, so before you can find I, you must know I1. And then we already know that the 4 ohms and then the 1 ohm resistor are in a parallel connection. So we're going to have 4 times 1 divided by 4 plus 1, which will give us a value of 4 on 5 ohms. And then this 4 on 5 ohms will be in a parallel connection with the 2 ohms. Okay, so finding I1, okay, finding I1 will be 10, okay, multiplying 2 on 2 plus 4 on 5, right? Just like the previous question that we solved. So let's find I1, which will be 10 times 2 on 2 plus 4 on 5. That gives us I1 to be 50 on 7. Okay, so now I1 will be the current that will be flowing through towards the direction where the 4 ohms and then the 1 ohm resistors are connected. Okay, and then we know that what will happen is that when this current gets to this node, it's going to split into two, right? It is going to split into two. But looking at the direction that has been chosen for I, it is moving towards the junction. Okay, it is moving towards the junction, which is opposite to the current that is coming towards that junction. So we will have to negate that value of I. So let's go ahead and find I. So I will be equal to 50 on 7, right? Multiplying 1 ohm, right? Divided by 4 plus 1, right? So that would be 50 on 7, right? Times 1 on 5. Okay, this is what you're going to have. So let's see what you're going to get. So 5 will go into this stuff and then go into 50 10 times. So then we are going to have 10 on 7. Okay, so let's what we're going to get. 10 on 7, okay, will give us a value of 1.429 amperes. But because of the direction of I, we will have to negate it. So we're going to have I to be equal to minus 1.429 amperes. So let's go to the next question. Okay, so we are on question 8, which says that what is the current in amperes in the 5 ohms resistor of the circuit below. Okay, so let's draw the circuit. Let's draw the circuit. So this will be the circuit. We have 5 ohms here. Okay, then we have the 7 volts voltage source here. Then we have another resistor here, which is the 2 ohms resistor. Okay, so this is 2 ohms. Okay, we have 5 ohms here, and then we have 4 ohms here. Okay, now let's go ahead. I'm going to find the current flowing through the 5 ohms resistor. So the current from the voltage source will come from this direction. Okay, and then when it gets to this node, okay, there's no element here, but when it takes this direction, it will come and meet these 2 ohms here. Okay, so for that reason, the current will take this direction. So because of that, the 2 ohms will be short circuited. And then when it gets here also, there's no element here, but there is 4 ohms here, so it will not flow through this direction. So the current will pass here and then go back to the voltage source. So at the end, the current in the 5 ohms resistor will be equal to the 7 volt over the 5 ohms. So let's see what I'm going to get. So 7 on 5, that will give us a value of 1.4 amperes. Okay, so that'll be the current in the 5 ohms resistor. So now let's look at question 9 also. So question 9 says determine the resistance in ohms seen between terminals A and B of the circuit below. Each resistor has a value of what? 1 ohm, 1 ohm. Okay, so let's look at how we are going to solve this question. Let me draw the circuit. Okay, so we have one resistor here, we have another here. Okay, then we have another here. Okay, we have this one also here. Okay, then we have one resistor here. Okay, then we have one here also. And then this is terminal A, this is terminal B. So each of the resistors has a resistance of 1 ohm, right? So let's write the values there. We have 1 ohm here, 1 ohm here. Okay, we have 1 ohm here, we have 1 ohm here, 1 ohm, 1 ohm, 1 ohm, 1 ohm, 1 ohm, and then 1 ohm. Okay, this looks a little complicated, but let's look at how we are going to solve this. Okay, so from here you can see that this 1 ohm here and then this 1 ohm resistors are in a series connection. Same for this 1 ohm and then this 1 ohm, right? So you can combine those two. This becomes 2 ohms, right? This also becomes 2 ohms, right? Are there any other that are in series? No, I don't think so. So let's continue. So let me redraw the circuit. So we have one here, we have another here, okay, and then we have one here, okay, and then we have one here also, okay, and then we have one resistor here again, then we have one branching here, okay, and then we have one here, okay, then we have another resistor here. So this is terminal B, this is terminal A. So we're going to have 1 ohm here, we have 1 ohm here, and then for this one, if you combine the two 1 ohm resistors, we have 2 ohms here, we have another 2 ohms here, we have 1 ohm here, we have 1 ohm, 1 ohm, and then 1 ohm. Okay, so let's continue and then see what will happen. So you see that these 2 ohms and then this 1 ohm will be in a parallel connection, right? So we're going to have 2 parallel 1, which will give us 2 times 1 over 2 plus 1. That will be 2 on 3 ohms, right? So at the end, okay, at the end, let me clean this. I don't want us to redraw the whole circuit again. So let me clean all that we have here. Okay, let me clean all that we have there and then put our 2 on 3 ohms there. Okay, so this will be 2 on 3 ohms. Okay, this is what we have. Okay, so now what do we do next? What do we do next? So what we can do next is that you have to consider one of the circuits to be in a star connection. Okay, so let's look at what I'm going to do. So we have this resistor here. Okay, we have one here, then we have one here. Okay, so this would be the 2 ohms, right? And then we have one resistor here, we have another resistor here, okay, and then we have 1 ohm here, okay, we have another 1 ohm here, we have 1 ohm here, we have 1 ohm here, and then we have 2 ohms here, and then over here we have 2 and 3 ohms, and then we have 1 ohm here. So this will be the circuit now. Okay, so let me free up some space, then we continue. So let me clean all this because you don't need those anymore. Okay, now let me send this up. Okay, so now this is our circuit. Now let's continue and then solve it. So now at the top side we can bring a star connection here, right, instead of the delta. Okay, so we can bring a star connection here. So let's name this A, let's name this B, let's name this C. Okay, all right, so let's find those resistance. So we're going to have Ra, okay, to be equal to 1 times 1, right, divided by 1 plus 1 plus 2. Okay, and then you're going to have Rb, okay, to be equal to 1 times 2, okay, divided by 1 plus 1 plus 2, and then you're going to have Rc, okay, to also be equal to 1 times 2, okay, divided by 1 plus 1 plus 2. Okay, so let's simplify them and see what you are going to get. So for the first one, you're going to have 1 times 1 divided by 4. Okay, that gives us a value of 1 on 4 ohms. And then for the second one, so you're going to have 2 on 4, which will be 1 over 2. Okay, which will be 1 over 2 ohms. Okay, here also you're going to have 1 over 2 ohms. Okay, so now let's simplify the circuit and see what you have. So let me draw the star connection. Okay, so we have one resistor here also. Okay, so we have another 1 ohm here, right? This should become terminal A, this should be terminal B. Okay, so we have 1 ohm here. Okay, and then for C we have 0.5 ohms, and then for B also we have 0.5 ohms, and then for A we have 1 over 4, okay, which is 0.25 ohms. Okay, and then over here we have 1 ohm here, and then we have 2 on 3 ohms here. Okay, so now let's find the equivalent resistance. So this was 0.5 and 2 on 3 are going to be in series, so you can add them. Okay, and then this 0.25 and then this one are also going to be in series. So let's add these two. When you add these two, you're going to have 1.25 ohms. You're going to have 1.25 ohms here, and then you're going to have 0.5, right, plus 2 on 3. That will give us a value of 7 on 6. Okay, so at the end the 1.25 and then the 7 on 6 are going to be in a parallel connection. So I'm going to have 1.25 parallel 7 on 6, right? So I'm going to have 1.25 times 7 on 6, right, divided by 1.25 plus 7 on 6. So now let's simplify that and see. So you have 1.25 times 7 on 6, okay, divided by 1.25 plus 7 on 6. Okay, so let's what you're going to get. You're going to get a value of 35 on 58 ohms. Okay, that's what you have. So what will happen is that this 35 on 58 ohms, okay, will be in series with this 0.5 here. Okay, you're going to have 35 on 58 plus 0.5, and then at the same time it will be in series with this 1 ohm and then this 1 ohm here. So you're going to have plus 1 plus 1. Okay, so let's see what you're going to get in total. So you have 35 on 58 plus, right, plus 0.5 plus 1 plus 1. Okay, so that gives us a value of 3.1034 ohms. Okay, so that will be the effective resistance for the circuit. Okay, so now let's move on to question 10. I think that's the last question. Okay, so now let's look at that. The question says, what is the value in ohms of R in the circuit below? Okay, so you have to find the value in ohms of R of this circuit. So let's look at how you are going to do that. Okay, so let's go ahead and solve this question also. Let me free up some space. Okay, so let's look at what you are going to do. Let me draw the circuit. Okay, let me draw the circuit. Okay, so we have 4 volts here, have resistance R, then you have 2 ohms here, and then you have the voltage from the source to be 10 volts. So you have to find the value of R in ohms. Okay, so let's look at how you are going to do this. So for this circuit here, you know that the sum of the voltages, okay, or the voltage from the source should be equal to the sum of the voltage drops in the circuit, right? So let's say that I is the current in the circuit. Okay, so I'm going to have 10 volts to be equal to the voltage across the R resistor will be 4 volts, okay, and then the voltage drop across the 2 ohms will be 2I, okay. All right, so the V there means volts, okay, so let me take it off, okay. So I'm going to have 10 equals 4 plus 2I, so let's find I. I'm going to have 10 minus 4 equals 2I, right? I'm going to have 6 equals 2I, and then I'm going to have I to be equal to 3 amperes, right? So I will be the current flowing through the whole circuit, and then you know that the resistor R and then the 2 ohms resistors are in series. So that means that the current that will flow through this will be the same as the current that will flow through this, right? So therefore the current flowing through the R resistor will be I, and then you know that voltage equals current times resistance, right? And then you know the voltage drop across the R resistor, so I'm going to have 4 equals I. We know I also, which is 3 multiplying R. So at the end we are going to divide by 3 to get the value of R. So R will be equal to 4 on 3. Let's change that to the math and see. So 4 on 3 will give us a value of 1.333 ohms. Okay, 1.33 ohms. Let me rewrite this again. 333 ohms. Okay, so that will be the value of R in ohms. Thank you very much for watching this video. If you find this lesson very useful, please make sure you like the video and subscribe to the channel so that if I upload these types of videos, you will be notified. Thank you.